circular motion and a simple harmonic motion under this subheading. That will be very powerful series. Let's go. Under circular motion, of course, by circular motion, we are talking about the motion of an object in the circular path. Now, we have three basic characteristics involving circular motion, and that is the constant speed. It has a constant speed, the changing of variable velocity, the centripetal acceleration, and then, of course, under this subheading or this topic, you should know very well that we'll be dealing with a lot of calculations. Of course, you already know that force is equal to mass times acceleration. And if I should call this equation 1, you already know that weight, which is also measured in Newton, is mass times acceleration due to gravity. And if I should call this equation 2, now you also should know this, that the centripetal force is mv squared all over r. Now, if I call this equation 3, I want you to know something. Remember that from 1, let me clean this. Remember from equation 1, I want to prove some formula before I start solving. Remember from equation 1 that we said that force is equal to mass times acceleration. And then we said that this is equal to mv squared all over r. This is centripetal force, right? And so if you should remove from here, if you remove this mass, it means that the centripetal acceleration is v squared all over r. So that is how this formula came to existence. If centripetal acceleration is v squared all over r, and then if you put it here, that's how I got this mv squared all over r. And this is the formula for calculating centripetal acceleration, centripetal force. Now, let me go to the work proper at the board. An object of weight, 150 newtons, move with a speed. So, first of all, this is solution. We have the weight, so the 150n, right? So it moves with a constant speed in meter per second, which is the velocity, right? And so that is the v is 4.5 meter per second. In a circular path of radius, so your r here is 3, right? So calculate the centripetal acceleration and the magnitude of the centripetal force. So the centripetal acceleration is v squared all over r, right? And so you already have that this is 4.5 all squared divided by r, which is 3, right? And so if you should point 4.5 squared divided by 3, the answer you should get is 6.75. 6.75. So this is 6.75 meter per second square, right? Now, they also want us to calculate the magnitude of the centripetal force. So, remember the centripetal force is m times acceleration, or is mv squared all over r. We have already calculated the acceleration. Now, look at, there's a trick here. We did not give us mass, we only have weight. But from equation 2, remember that your weight is equal to mass times acceleration due to gravity. And so your mass is weight all over g. And so your weight from this is 150 divided by your 10. And that should give you 15. And so the magnitude of centripetal force is 15 times 6.75, and that should give you your force. That should give you your force is 101.25 Newton. That is 101.25 Newton. In physics, please never forget to write the SI unit. Never forget to write the SI unit, please. This is Z. So let me continue with the next example. With the second example here, if an object of mass 4 kg goes round a circle of radius 0.5 meters in 3.142 seconds, what is the force towards the center? And you take your pi to be 22 all over 7. Now, this question is very simple, but you have to know something. You can see where I wrote, note the distance around a circle is the circumference of the circle. And the formula for calculating the circumference of the circle is 2 pi. Now, they want us to calculate the force towards the center, and F is equal to mv squared all over r. From the question, we have mass is already given to be 4 kg, and we have the radius, which is r to be 0.5, and our time t is 3.142. Now look at the problem here. We don't have velocity, and without velocity we can't calculate it. Now remember that velocity is distance all over time, and remember I said the distance around the circle is circumference of the circle, so the distance here is 2 pi all over your time, which is 3.142. And remember that 22 all over 7 is 3.142 all over 3.142. So this cancels this. So your velocity is 2 meters per second. Now, if you have already gotten your velocity to be 2 meters per second, all you need to do is insert it into this formula and your answer flow naturally. So this will give you 4 times 2 all in square all over the radius, which is 0.5. So if you punch your calculator, what you will get as your answer is 32 newtons. So you get 32 newton. Remember, on this channel, I like starting with the basic, then I'll jump right into the very hard section. Note this very well. We have the relationship between linear velocity and angular velocity. So V is equal to WR, where this is the linear velocity and this is the angular velocity, while this R is the radius, right? Now this is the relationship. Now remember, from centripetal force, if I call this equation 1, from centripetal force, F is equal to mv squared all over R. Now, what I want to do, let me call this equation 2. So what I want to do is I want to put equation 1 into 2. So we'll be left with F is equal to m into WR squared all over R. Let me call this equation 3. So opening the bracket, you have F is equal to m W squared R squared all over R squared, like this, right? So of course this will cancel this, and so you are left with F is equal to mw squared. All right, so we don't have, this is not 2, this is R, so w squared R, right? So this is equation 4, and with this equation 4 we are going to use it to solve a lot of examples. So I wanted to prove how that formula is gotten, so that if I start using it to solve examples, you will not actually find it difficult. So please note that into your writing material. And so you have this video, a stone of mass, you have a stone of mass 500 grams tied to a rope 50 cm long, is whirled at an angular velocity of 12 rad per second. Calculate its centripetal force. Now, this formula I proved. Please note that the SI unit of velocity is meter per second. The SI unit of angular velocity is rad per second, and that the radius is measured in meters. Please note it very well. So using this, my formula already proved that F is equal to mw squared R. Now all I need to do is insert into my this formula, and the answer will flow naturally. But please note that the mass must also be in kg, and so we are going to do a little bit of conversion. So from here, the mass should also be in kg, and so from this place the mass is in grams. So this is mass in grams, divide it by 1000 to convert it to kg, times your angular velocity, which is 12 all in square, times the radius, which is 50 cm, convert it to meters, you divide by 100. And so here you have 0.5 times 12 square times this 0.5, and if you punch it in your calculator, the answer you should get is 36 newtons. So you should get, so the magnitude here is 36 newton. So please continue noting the formula. We're going to keep on solving. A force F is required to keep a 5 kg mass moving around a circle of radius 3.5 km at a speed of 7 meters per second. What is the speed if the force is tripled? Now, the force F, we do not know the force F. And remember, from the formula already gotten, that F is equal to mv squared all over r. So the first thing is for you to calculate to get your force. So how can you get your force? You already have mass. Your mass is 5 kg. Moving around the circle, your radius is 3.5 times 1000, because I want to convert it to meters. That should give me 3005 in meters, right? Now, we have a velocity of 7 meters per second. What is the speed? So I want to calculate first the force. So the force, which is equal to 5 times the velocity 7 square divided by 35, and that should give you 70 newtons. That should give you 70 Newton. Now, please, from the question here I have, is not in kilometers. The question is in meters, please. So that the question is in meters here. So, but if it's in kilometers, you still times by 1000. So the question is in meters here, so we don't need to times by 1000. So you divide everything by, the question I have here is in meters. So you divide everything here just by 3.5, because I calculate I couldn't get 70. And so your answer is 70 newtons, right? Now, if you now want to, they say what is the speed if the force is tripled? So all you need to do, if you have 70, 3F, that should give you 3 times 70, and that should give you 210. Now, they want us to calculate half mv squared all over r. They want to calculate the speed when the force is tripled. And so from here, you can see that this is mv squared all over r. So v squared is equal to fr all over m. So v is the square root of fr into m. So we have the square root of 210 times 3.5 divided by your mass, which is 5 kg. So, and if you should punch that very well into your calculator, what you will get is 12.1 meters per second. So you will get the velocity to be 12.1 meters per second. So know the conversion process, how to convert from grams to kilogram, how to convert from kilometers to meters. And if you should learn those things, you won't have problem in this course. That's all for this video. Thank you very much.